Got it. Hey, hello and welcome everyone to Scalawags number 38, The Sound of Dotty with Martin Odersky. I'm one of your hosts. I'm Josh.
I'm Seth.
I'm Dick.
I'm Isaiah.
Isaiah.
Yeah.
And we have Martin.
Her name right now is Isaiah, and in a few hours, what's it going to be? What do they call
when
you?
I go back home, it's Heza.
It's Heza. Okay, cool.
I'm going to share a pop culture reference that I think probably only people from England will get, but I expect they'll find it quite funny. There's a chocolate company in the UK called Milk Tray, and they have an advertisement where a super secret agent guy dressed mostly in black breaks in and leaves chocolates for the lady, and Martin looks like the Milk Tray man today. He has the black turtleneck and everything. It looks like he's going to break in and leave chocolates for people.
Okay, I'll definitely try and research this for the show notes so everyone else can get in on the joke.
The Milk Tray man, yes.
We have to do a comparison picture.
Exactly. But it better be accurate.
It is pretty close. The first thing I thought when I saw that was, oh, Martin's the Milk Tray man today.
Yeah. Well, welcome. We see that you've been very active with blogging, which is really exciting for us all. Really exciting.
Yeah.
You have to keep it. Yeah, it's you take some discipline to really crank out these blog posts, but it's good to do that. So I haven't done it for a long time. But since my first blog this year was a vow to blog more often this year, so I have to keep up with it.
Excellent.
Well, I think we want to start with just some general how's Dotty going? Like what's
state of the Dotty.
Yeah, if you were to, I mean, there is the blog article, right, which shows the dot calculus and some problems you've run into. But what's the state of Dotty right now?
So Dotty is essentially a project, mostly a compiler, some SPT plugin, REPL, what we're working on. That essentially is a advanced research experimental platform for a future Scala, and that has taken a long time to come along to mature. So I've been working on that for about 3 years now, and it's finally getting where we can look at releasing it at some point for like the really intrepid advanced users who are not afraid of bugs and who are not afraid of mystical error messages and this sort of thing. But hopefully we'll have something by Scala Days or the mid of the year that it's actually somewhere on Maven, and you can download it and you can play it and watch it crash.
Cool.
Is the SPT support in place enough that people can try it out that way even without a release?
Yeah, so the latest SPT has a Dotty, I don't know what it is, a Dotty source or thing. So you can configure it to use Dotty instead of the Scala C compiler. Yeah. But it doesn't. It doesn't do incremental yet for Dotty. So you'll be back to essentially whole program compilation. You have to compile everything from scratch if you use that SPT.
But that should be faster, right?
It's a little bit faster, yeah, but I guess it's sort of it's a little bit faster, but of course it's much better if you can do incremental. But incremental is definitely something that we want to do soon. It's just one thing after another.
Yeah.
So then I guess to ask a more basic question, what's the status of the backend? The backend is totally solid now. You have a fully trustworthy backend that you're using, or how does it work?
Well,
can I safely generate files that I can just load and run on any JVM? It's all fine. I can trust it.
Any JVM, I have no idea. We never tried it on anything except OpenJDK. So I don't know. You'd have to try that out.
This backend is built on Tasty, right?
Yeah.
Okay.
Yeah. That's or rather the cross module linking is built on Tasty. Yeah. So right now we don't really do. So there's another project by Dimitri called the Linker, which looks at essentially whole program optimizations built on Tasty. So essentially you read in the whole program and you ingest it using Tasty, which is this format of abstract trees, and then it does very, very aggressive optimizations. But that's something that's also not yet done, but it's something that is sort of on the currently in development, and looks. I mean, if that comes along and keeps its initial promises, it will be very exciting indeed.
Just so that we're not having too many confusing acronyms. Now, Tasty. What was the original? Like, what is Tasty again, and what's the point of Tasty? Why did you introduce it?
So Tasty is called typed abstract syntax trees, and it's essentially an intermediate format, a high-level intermediate format. So essentially, when the Scala compiler or the Dotty compiler reads a program, then it converts the program source into parse trees, and then it figures out the types using the type checker, and then the trees, essentially the output of the type checker are trees that have all the type information in them. And that's at that point we serialize the whole thing. So it's a very Scala-centric format as opposed to, let's say, Java bytecode. You treat it at a very high level before a lot of the essentially translations into lower level Java idioms have been done, and so you don't. The higher the level, the less information you lose. That's the advantage there. So that's our essentially our intermediate format between Dotty modules. They sort of see each other using this Tasty thing. For Dotty modules can also see Scala C modules, and then of course they use the Scala C pickling information, which essentially keeps the signatures. That means the names and the types of everything you define, but it doesn't give you the code. So essentially, the Scala signatures they don't store the code. To get the code, you have to go to Java bytecodes, and then that you see at a completely different level, which is very hard to relate with the high level signatures that you see when you read a program or when you type check it.
So this might be a divergence a little bit, but how many projects have you compiled with Dotty outside of like Dotty itself or the Scala compiler?
I'm maybe, I don't know, maybe a handful, something like that. So what we did do is Dotty compiler, most of the Scala standard libraries, so all of the collections, which is the biggest part of the Scala library. No, well, all of the sequential collections, I should say. We didn't try parallel yet. No, we did try parallel. Sorry, yeah. All of the collections. This collection Strawman, some third-party projects that Guillaume tried to do. So I would say overall a handful so far, not more than that.
Okay, cool.
Does Dotty have a REPL? Can I just open up a REPL?
To it.
Oh, sorry.
No, that's okay. No, go for it. I was just about to ask the same question. Yeah.
Well, it has a REPL that waits for improvements. So a couple weekends ago, I took the weekend to hack together a REPL. Essentially, I took an old REPL of Scala when it was still small, and I was able to understand it in a weekend, and took that one and adapted it to Dotty. And so that REPL exists now. It's called .I, so dot interpreter. And but there's a lot of things that need to be added. Tests, JLine integration, we haven't even that yet. So you're advised to run it in an Emacs shell or something to get line navigation and things like that. So it's a project where I thought, well, we really need outside contributors, which we need for a lot of these things, because essentially it's not run by any company. It's really an open source volunteer project, and because I know it's really hard to get off the ground with the REPL, I thought, well, I'd spend a weekend to do sort of a proof of concept. So now you have something that awaits improvements, and hopefully we already got our first volunteer who said, yeah, he would like to contribute. So that's
great,
cool.
Yeah.
So and related to that, then, is there a Gitter channel or something like that people can join to sort of chat and coordinate and that sort of thing?
Sure, that's also called Dotty.
That's Dotty channel. Okay, got it.
Lamp EPFL/Dotty.
On GitHub.
On GitHub.
Excellent.
And you have a link to the Gitter channel in the README, I hope? Or no?
If not, we can contribute that.
Hey, yes. It's already there.
Oh, it's already there. Okay.
That'll be the first thing we ever do on the project.
Yeah.
Possibly
Yeah.
the most important thing we ever do on the project. All right.
So I have a question that's about the community and the reaction to the work on Dotty. One thing I've seen is that some people are concerned that that you and your lab are sort of off working on this other compiler, and that makes some people worried for Scala that you're doing this other thing. How would you respond to that?
Well, I guess I would respond that you can't make everyone happy. So when we were still hacking on the Scala compiler, there were a lot of people said we should stop doing that and we should just essentially let Scala stabilize and mature, and we should concentrate on a research compiler, which we did. Now people are not happy about that either. So I think it has. So there are advantages and disadvantages to both of things, but I think Scala is about you to have a big jump ahead. So like C# had this a couple of years ago when they switched from the old code base to Roslyn, which was essentially the new C# project, the new C# compiler written in a mostly functional style in C#. And ever since, essentially, the project has been completely rejuvenated, and essentially there are much higher velocity of features and much more excitement and things like that. And I talked to Mats Torgersen, who's the project lead for C#, and he said, well, actually, we're stealing a lot of things from Scala. Have you noticed? And I said, yeah, great. I said, well, we could do that because now we have Roslyn, and we can just move so much faster. Before, we could maybe put in one language change every 2 years because it was so hard to change that compiler. Mm-hmm. And I think for Dotty, we're sort of in Scala. Scala C is not that bad yet, but I mean, you can notice that I believe that change has slowed considerably, which is, I think, just right for a lot of people because, of course, change is the opposite of stability, and a lot of people value stability. But at some time, then there's a pent-up demand where all the changes people wish for sort of accumulate, and then I guess at some point it's good to make a big change, jump forward. And at some point I think that will happen, and my prediction is it will probably be on the Dotty code base, but that's yet to be decided. It could also happen that at some point we completely renovate Scala C and backboard a lot of the Dotty things into Scala C.
So that's actually a great sounding board for the first question I had with the blog post. Because you're talking about changes and pent-up changes and things people have been asking for. One of the things that people definitely asked for a lot in my circle, which is probably not general population, but they wanted to have the type inferencer fully spec'd, completely spec'd and known exactly what it's going to do. Well, the first blog article gives us the calculus. What are the chances of us getting a fully spec'd type inferencer in Dotty? Because I know there's a lot more complications than just inferring the perfect, least upper bound, because that's not always what you want to give the user.
What languages do you know that have a fully spec'd type inferencer?
I don't know.
Standard ML?
Yeah. Standard ML would have one. Yeah, I think they would qualify. Yeah. And it might be the only one. I don't know. Maybe OCaml. I'm not sure, but I'm not sure whether that's the case. So Haskell definitely not. But I mean, you're right. I think it's a matter of degrees. You can definitely do a much better job explaining how type inference works and what the limitations are, and still being short of a fully spec type inferencer. But it's definitely a worthy goal to get there. Yeah.
Well, do you think I guess that's a great question. Is it worth having a fully spec type inferencer, or is it better to have a little bit of flexibility? I know, learning the Haskell type system, writing a type inferencer was one of the first articles I read.
Yeah.
And there was a whole bunch of unknowns about how it works and stuff at one point. So
Yeah, I think you're right. The problem is, and I think that's sort of the problem that hit SML. Once they had a fully spec type inference, a fully spec everything, essentially the language fossilized because you couldn't change it anymore. And then there was OCaml, which was moving much faster. And I mean, you saw what people used in the end. So I guess OCaml is used much, much more than SML. So there's definitely a danger to specing everything and then keeping to the spec. I agree with that. So I guess one has to find a middle way somehow, because I think it is rather embarrassing how underspec the current Scala type inference is. That's definitely a sore point.
Well, I'm really glad to see dot calculus.
Yeah, actually, on that note, so there are two very informative blog articles that you've written, both about this calculus and current things that you're struggling with in the type system, changes that you're talking about making. Rather than let me try to summarize it and get it all wrong, would you provide a quick ESPN the highlights of these two blog articles? What's the essence of these blog articles for those who are listening that haven't read it yet?
Well, I already gave you the essence of how short I could do it in the blog articles, and I realized they're rather...
Just distill it more. Distill it more.
The essence of the essence.
The essence of the essence. Essence squared. Yes.
So, well, the first one was essentially something we've been working on for a long, long time. I guess it goes back to 2007 or 2008. To come up with a really faithful mini language that we can say what should be the core of Scala. That we say Scala is basically built on a thing like that. Other languages have that. A lot of the functional languages have more or less lambda calculus or system F, which is typed lambda calculus. So some variants of system F as their core language. And for Java, there was FJ as the core language, and a lot of people have built on FJ. So once you have this mini language, the idea is that then people can build on it and can essentially formalize or think about their possible extensions or possible other aspects in terms of this mini language. And so that's what we try to do. And one thing you need to do when you do that, so essentially that mini language, you define what the language is, so you give a grammar, you define what the typing rules is, and you define how it executes. And of course, all that is cheap. Words are cheap, definitions are cheap. The hard part is to then show that when you execute your program, that essentially the types get preserved, so that essentially the types don't lie, or otherwise say that well-typed programs don't go wrong in certain ways, right? So they don't crash in certain defined ways of the meaning crash. And that's sort of every respectable calculus has to have that, the so-called type soundness theorem. And that was surprisingly super, super hard for Dot. So you couldn't just crank that out. And there were many, many people who tried for a long, long time to come up with that. And so now we finally have it. And what's more, because these things are complicated, these proofs, now the gold standard is that the proofs themselves should be essentially checked by a computer using theorem prover. So we used Coq, which is written actually in OCaml, and it's sort of the most popular theorem prover probably nowadays. So we used that to prove the type system for dot sound. And that took a long, long time. And it wasn't a long, long time just because of fiddly details, because we needed a long time to really wrap our heads around the right way to approach things. We had many, many false starts there. So that was the dot thing. And once we had that, it actually gave us some insights to say, well, for being sound, so for being correct, what kind of properties need to hold, because those were the core properties that the proofs rests on, and that property was essentially that we say, well, we can't really, if we have a type, we can't really judge that it is consistent a priori, because it could have abstract type parameters and abstract types, and then they might be refined later in some incompatible ways, and then we might get a type that's just wrong. And there's no single point in the program where we can find that out. So the only thing we can find out is if we actually create a value, like you write new and create an object, then at that point we can check that the type of that object is actually consistent. Otherwise, I mean, that would be a disaster if you could create an object where essentially you would have inconsistent definition of a type member or things like that. And sort of the the difficulty was to find the right leverage to make that into a full soundness proof. And once we've done that, we also found that leverage actually we can generally translate into the programming language, but there are a couple of things where we can't do that, so we have to tighten the rules. And so that gave us a good insight how to essentially tighten certain type checking rules in Scala to make it essentially safe, and how to attack things that were already previously known to be unsound, or that we had shown then that would be unsound.
So one example was the type projection.
Right. So type projections is one of the things. Yeah. That in general is unsound, and it's also Turing complete. So essentially turn Scala into a giant type level, Turing complete, unsound computation engine. Yeah. So we will have to get rid of that. So right now, Dotty still allows it because we want to be as compatible as we can with Scala, but be warned, it's on its way out at some point.
So a question regarding that, and this is actually from Daniel's comments. You guys had a quick little discussion about H-lists and how computing the type of an H-list. Is the implicit workaround where you can still do all of the Turing complete type system checks that you want to do just using implicit jumps? Is that's sound if you do that? That's
sound. Indeed, that's sound, because when you create an implicit, you create an actual object, and at that point we know that the types are sound. So you can't go wrong with implicits.
Nice. I think maybe I'd like to explore this field a little bit more, but in a more general sense. And I know this is a question that we've hit multiple times. Martin's probably tired of answering it, but I think it's worth asking and answering one more time, maybe. Which is, if we fast forward a couple of years into the future, and assuming that something like Dotty has become the Scala compiler, what are the changes that are going to affect developers going to be, and what can they do to start getting ready for that if they want to, ahead of time, make sure that they have the minimal amount of work to rewrite their code?
Let me think. So stay away from projections, yes, that's number one. Macros will be simplified a lot and will be changed. So essentially, macro code now will probably have to be rewritten, but the new version will be far simpler than the current one. So there's bad news and good news. Bad news is you have to rewrite it. The good news is everything's going to be much simpler.
That's good. So, one random question about type projections. Is it actually generic type projections like list pound t, or is it like if I do this dot type pound t? Is the this dot type one more okay because you have an instance?
Yeah, sure. This dot type pound t is just an abbreviation for this dot t, right? And that one you still have. So so you can always select from a path. You can select a type, or from a singleton type you can select a type. You can also select a type from a class. It turns out that's not a big deal. So that was actually the original motivation for having type projections, that we had to simulate Java inner classes somehow. So if you have an outer class and an inner class, then you write outer.inner in Java. That would work in Scala because outer would be the outer companion object. So we write outer hash inner to do the same thing. And that's still, there are no problems with that, so we can keep that. It's just essentially that the prefix has to have certain rules, that the prefix must sort of be statically known to be always consistent. And that means most of the interesting rules of type level computations using projections, they would break those rules.
Yeah, so essentially, a lot of people who use hash probably are okay. It's just the really advanced use cases are the ones.
Yeah, I guess if you use it and don't think much about it, you're probably okay. If you think it and say, "Wow, that was a brilliant trick," then I would have my doubts.
Okay, so I think the question everyone is asking themselves is, will shapeless work?
Miles actually weighed in and says there's no problem in dropping it because he thinks type projection is very fragile anyway and you should use implicits. So I think at least Miles, I don't know whether current shapeless would work, but at least Miles doesn't see a problem in adapting shapeless to that new system.
Cool.
Got it.
Sorry, I didn't want to. I wanted to dive in on that first point just to make sure I refine it. So the second point was, or I didn't want to cut you off.
Oh, meta and macros. So that's going to be so essentially for macros. What we want to do is sort of a two-stage system. So the first system is super simple. There's just an inline thing, which is essentially partial evaluation. You just inline things, and that gives you sort of compile time computation, forced compile time computation using inlining, and then there's on top of that is essentially a Scala meta, which lets you then essentially analyze and generate ASTs using quasi-quotes. So that's sort of the two levels. And a traditional macro would be written just an inline def, and then the body would be at some point you write meta and then embraces. And once you write meta, then you are at the meta level and you see essentially the code as the compiler would see it as a tree, as a syntax tree that you can express with quasi-quotes. That's the idea of the new system. And in particular, one of the motivation was not to use reflection anymore, because that seems to be very fragile, and also we have to think of that we are about to become a multi-platform language, and we can't just base it on reflection that's only available on a single platform.
So one of the common uses of macros, and I should say common because I've seen it in a lot of different libraries, is the serialization macro, where you auto-generate a serializer for a class. And a lot of these, basically, for case classes, assume they're the bottom of a hierarchy. And for sealed traits, they want to inspect the sealed trait, which you are safe to do so in a file because you should know about all of the possible expansions. Is that still going to be supported? Because that essentially is a little bit of reflection there across.
That we actually gonna do out of the box. So we're gonna do much more scrap your boilerplate directly on case classes. So the sort of the simple thing of saying, well, we just map everything to sums of products. If you have, let's say, a sealed trait with a bunch of subcase classes, the compiler is gonna support that out of the box. Doesn't do it yet, but it will. So that's the plan. And from that on, you can base serialization on it without any metaprogramming, without any macros.
You touched on this change that's happening in Scala, that it's the list of supported platforms is changing. So back when Scala was originally designed, it was JVM and .NET, and now the two big ones are JVM and Scala.js, and I guess LLVM is coming. Is there anything that you're doing differently in Dotty that is really being influenced by that list of platforms?
Let me think. Well, there's one. It's really tiny tweaks, but there's one thing was that the LLVM work wanted to do, and that's we're not gonna allow monitor operations such as wait and notify on all objects anymore. So there's going to be an interface monitor, and you have to inherit from that to have essentially lock functionality that you can do synchronized on that object and things like that. Because it's just too expensive for native code generation to assume that every object can be a lock. That's just crazy. And I think it makes a lot of sense to do that anyway. There was a blog post recently about if Java was designed today, what would it do differently? And that was one of the things that you say, well, it just seems weird that every object can be a monitor. So that was one thing, and the other thing is also super technical, prompted by Scala.js, and that has to do with is instance off and as instance off of essentially small integer ranges, byte short char. Where previously, because essentially in Java all these types are boxed, so you say if you hold a number, a Java number, and you say is it an instance of byte, then it actually looks at the tag, at the class tag, and says, well, if it was created as a byte, it's a byte, otherwise it isn't, even if it's 0. And that's too costly for JS, because in JS we use the native representation for these numbers. We don't need to box them. So the plan is to change the rules to say, well, as an is instance of byte would answer true if the number was in the byte range, and not only if it was created as a byte, which I think, if you ask me, makes sense. So far, those are the only sort of concessions we had to do to different platforms, and I think they're both pretty tiny and reasonable so far.
Yeah, well, that sounds like a good sign. I can imagine that most of the difficulty might be in the standard library rather than in language stuff per se.
Yeah, that's true. The standard library will, of course, be not the whole standard library will not port either way. So, and we have to see how much of a problem that will be for LLVM. For JS, it doesn't look like much of a problem because people are used to a different environment anyway.
Yeah. I gotta say, I'm very much hoping there's not a lot of as instance of with JavaScript, or is instance of, I should say. I just feel like that's a rough scenario. Yeah,
actually, in JavaScript, because there's a lot of as instance ofs in the general code, and it turns out that the JavaScript interpreters and backends are much worse than the JVM hotspot to deal with that. So actually, there's an option, there's a fast option to turn as instance of checking off in JavaScript, and it gets you something like 30 or 40% speed improvement. So it's not something to be scoffed at.
Right.
Yeah.
Wow.
That's cool.
So, sorry, Seth, I cut you off. What was your?
I forgot already.
Okay. Cool. We actually have a user question. I'm gonna let the audience know that you can ask questions. There's a Q&A app, or you can ping us on the Scalawags Gitter channel. I don't know if anyone's still on IRC. Do we do IRC? I don't think we do anymore.
No.
Yeah, we've abandoned IRC. We're hipster now.
Like the rest of the community, I think we've switched to Gitter.
Yeah.
Entirely.
All right, so let me click this button here. All right, so the question is from Rajesh Pitti, which I mispronounced probably. Will Dotty completely replace Scala compiler, Scala C?
Well, I think there are no plans for that yet. If Dotty becomes standard Scala, then it will be sort of a major version bump. So it will be Scala 3 or something. We're not decided yet whether it's going to be 3 or what it's going to be called. But it will be as big of a jump as, let's say, what Swift is currently considering. That, let's say, Swift 3 will actually be quite radically different from Swift 2. And so it will be a risk, and that means that if I will take Python as an example, that Scala 2 might be around forever. Or people migrate and they're happy with 3, and then it might go faster. So no predictions, I guess.
So I guess as a follow-on, you already mentioned that you're keeping Dotty compatible with existing Scala for type projections, so that you can still compile things at both sides, even with the unsoundness problems. What kind of basically adaptability plans do you have so far for taking existing Scala code and compiling it on Dotty?
So, so we try to be reasonably compatible, but there are areas that will break. We try to bridge a lot of these areas with rewrite techniques. So that's still a postulate. So right now the Dotty compiler just has a switch language Scala 2. And if that's on, then it will be a lot more forgiving to sort of Scala 2 idioms that are no longer valid in Dotty than otherwise. And we'll warn you, and it will tell you in most cases how you should rewrite. But of course, it would be nice to rewrite automatically, and hopefully we'll get to a tool like that. That's another project that would be great as a community project if somebody took that on. So we plan on having automatic rewriting and the language mode. And then my personal bar is to say, for not too exotic Scala code, if you do one manual intervention in maybe 1,000 lines, then that's okay. That's probably the best we can get. Which is, the code base is around which have 1 million lines, so it's a significant upgrade pain, and I've completely realize that, but it's probably the best we can do. 1 in 1,000. If we can get there, then.
Is the plan like one in 1,000 manual things, but then the automated tool would handle like one in 1,000 of those kind of thing?
No, the 1 in 1,000 manual and the automated tool could rewrite, I don't know, 1 in 100 or 1 in 1,000 or something like that. I mean, the basic things like no more procedure syntax. If you use a lot of procedure syntax, and that's of course something we should rewrite automatically. And there are other things like use and instead of with for compound types, things like that. So a typical program could have quite a few of those, and it's not realistic to ask people to rewrite that manually.
Yeah, I guess Python 3 was a good lesson for everybody to figure out what you need to do.
I was actually just going to mention that. So having been through this process just recently, because we've somewhat revived the Enzyme project, and one of the plugins for that, the Sublime plugin, is Python based. And we just upgraded that from the Python 2 to the Python 3 code base. There was some pain involved because there was, and I would say probably more than 1 line per 1,000. It was probably more like 1 line per 100 that needed manual intervention. It still wasn't horrible. It was mostly 4 comprehensions. You just got into a groove and you just kind of went through and, bit the bullet. And I think Rory and I just spent an evening sort of going through and trying to find them all. It was okay, it wasn't the end of the world, and once it's done, it's done. So
and of course it's much nicer if you have a compiler with a type system, because then you get all these things at once rather than bumping into them when you're running the code.
We got quite used to finding something and then cooking up a search for it, a text search for it, to try and find the others that we could then identify quickly. And so there was this kind of awkward process of, that's the problem. Let's see if we can find that pattern somewhere else with a find. And
it's like you're writing a wimpy, loosely typed system to find things. Interesting. All right, we have another audience question from Regis again. Is there plans for Scala VM, or is the JVM good enough for Scala? I remember you mentioned something about this with Tasty, but I'll let you answer the question.
We're definitely not going into the VM. So the people I know, the people at EPFL, the people at Lightband, the community I know, it has no plans to write a new VM because I mean that's just much too big a project and much too distracting a project. What Tasty could be in a way is a sort of compile time platform that can transparently map to different VMs and different versions of libraries and VMs and things like that. So it could become a platform, but it wouldn't be a VM.
So it'd be, instead of just-in-time compiling, it'd be way ahead of time compiling.
Yeah, I think that's a good way to put it. Yeah.
Watt compiling.
Yeah, Watt. That's nice.
Cool.
I have some more user feedback here.
Okay.
So this is my dog, Dotty.
Dotty.
She would like to know why you misspelt the name, because it should end with an I and an E rather than a Y.
I think that's just too bad.
Okay.
Fair enough. Do you have a logo for Dotty the compiler yet? Because I think we have one for you. We have one for you.
Oh, yeah.
You can tell she's not really that upset by the whole thing. She's pretty relaxed about it, really.
Okay, so I have a couple of other questions that aren't user questions, but I think that they're questions that could be interesting to the general public. So if I was interested in getting into Dotty without ever having looked at it before, and I don't know, I've had some experience in compilers when I was doing my master's or something, but not like a big compiler person. But I think I want to help out with something. I'm sure I can help you somehow with some task. Do you have some can you name off the top of your head like 2 or 3 like low-hanging fruit projects that somebody who would be interested in trying to contribute could start with? Is there some modest projects that you can think of that people might be like, hey, yeah, I might try to spend my weekend on Saturday afternoon trying to make a pull request to Dotty. Do you have some ideas?
JLine integration for the REPL. We have actually our issue tracker has a low-hanging fruits category, so
I
you
didn't
can
see
just
that
look it
one.
up there.
These are the
Hold
things
on.
we need. We need
Awesome.
to get some of these in links in the show
I
notes,
was
so people.
I was looking at the wrong.
I'm going to throw out there that I don't know if J-line is low-hanging fruit. I think you're going to spend
Well,
day on
to do it right is not low-hanging.
day,
Yeah.
a day on J-line at least because it's exciting. Yeah.
I
Anyway.
think there should be. I think there should be a further categorization, which is requires patience. So it's low-hanging fruit, but requires patience.
Right.
I mean, there must be all kinds of REPL stuff that would be sort of
Yeah,
easy
there's
to
all kinds
add.
of REPL stuff under that. The most stuff that we have an internal checking tool, which essentially the compiler does for sanity checks after each major transformation. It checks itself, and there are a bunch of essentially other properties that we might want to check that way. So that's some of the other issues, which is sort of you wouldn't break any. Well, if the tests pass, then you didn't break anything, but you have sort of strengthened the compiler framework and made it more robust. That's another branch of it. Yeah.
So actually, in the same sort of thread of how do I get involved in Dotty, I don't know where to start, we have another user question. Pedro Furlaneto asks, well, if I haven't read anything about Dotty, how do I actually get into it and start learning it? So what would you recommend for people who want to get their feet wet?
Okay, so we haven't really done a language spec or anything like that yet, and a lot of it is not yet done and still in our heads. So the things we did do, most of them are actually also in the issue tracker under closed issues and that thing, if you did it already, and that has the label language enhancements. So we sort of try to follow a sort of the zip process in some way to sort of for every enhancement we write an issue and then you can see the cross-reference of the pull request that closed the issue. So there you see sort of some of the things that the language does differently. But I'm actually not sure now whether in particular the early changes are there yet. So I should say, so currently our main focus really is have a new compiler platform that lets us move faster in the future. And right now our main focus is really compatibility with current Scala, because we know that essentially that's where everybody is. So people have to move over. So a lot of the new stuff that we have planned for Dotty is actually not implemented yet. Like the thing with inline and meta that I told you about, that sort of plans. I'm not sure we have an issue. We might have, but we discussed it in detail what we want to do, but it's not implemented yet. Because we thought, well, before we actually have come out, the important thing is to be faithful to Scala 2 to the degree that we can do that. So we concentrate on that right now.
I have a suggestion for something that people could work on, and it may actually be too early for this, but eventually, in order to be sure that that Dotty can compile real Scala projects, like the gold standard is going to be hooking it up to the Scala community build. Now, the community build, that's huge, but the community build begins with a few projects that are like cornerstones of this whole tree of dependencies. So that includes some of the Scala standard modules like Scala parser combinators, but the really big one is the test frameworks like Scala test, Scala check, and specs. So if someone wanted to sort of adopt those test frameworks and try to get some version of them running on Dotty, even if it were just to find out like what the biggest challenges were, I think that would be really, really valuable.
That's an excellent suggestion. Yeah. I agree.
Also, hey, by the way, on this topic of things to do and how to get involved in contributing, does everybody know that we got accepted as a Google Summer of Code mentoring organization? So we're able to actually fund people to work on several.
You could contribute and get paid?
Yes, Google will pay you to contribute to the Scala compiler. And actually, we have there's a Google Summer of Code page, which actually we should better link from the front page of Scala Lang, with a list of suggested projects. There are 2 Dotty projects in there. One is well, one I think we have somebody for already, but which is the Dotty documentation. But another one is the Dotty REPL. I don't know if somebody would like to take that yet. But I mean, Martin, just a footnote. If you could distill down some projects that you'd like to see done, like I mean, perhaps some of this, integrating bits and pieces of, or rather like running Dotty on some test frameworks, or trying to better test Dotty, things like this.
Yeah.
These things could maybe be proposed as Google Summer of Code projects. Maybe you could append some of these ideas to the list of projects on the Google Summer of Code page. But the main point here is that you don't have to take one of the projects on the list. You can also, there are instructions on the website, but you can also suggest projects. So if somebody has an idea about something that they would like to work on, they can write to the mailing list, which is linked to in the Google Summer of Code page, have a discussion, and find a potential mentor if there's something that's on the list that people don't want.
Yeah, I also want to throw out there, for those of you REPL people, you don't have to use JLine. If you would prefer a poorly implemented and very buggy version of ANSI REPL-ish stuff built on reactive collections, just look at one of my repositories called Streamers. It's got everything you need for a very buggy REPL experience. I promise you. Promise you. All right. With that, I'd like to say thank you so much, Martin, for coming
It was a pleasure. Thanks. It was great to see you all again.
Yeah, definitely great to see you. Thanks, everyone. And hopefully we can do this again soon.